So in this video, we're going to talk about a tool called the three-dimensional Mohr circle. A 3D Mohr circle is used to determine the magnitude of the maximum shear stress within a stress element. The maximum shear stress is important to know because you can use the maximum shear stress to predict whether or not uh, a material will fail under a given stress condition. So, if you recall from last few lectures, we talked about stress, finding the principal stresses. So for a given state of stress in 3 dimensions, we have 3 principal stresses: sigma p1, sigma p2, and sigma p3. So in the principal stress state, we have only normal forces are acting on our stress element. So we have our 3 stresses: sigma 1, sigma 2, and sigma 3. So each of these stresses has, if we look at each of these individual planes, we can look at planes A, B, and C. We can draw an element or a representative 2D element, and we can draw a Mohr circle for each of those elements. So in the first case, if we had uh, case A1 or case A, which has sigma 1 and sigma 2 on it, and we drew a Mohr circle for those 2 points. All right, the maximum stress within this one would be equal to, the maximum shear stress would be equal to sigma 1 minus sigma 2 divided by 2. Okay, and we can repeat this process for our second element, element B. Okay, and element B is going to be the y direction is going to be sigma 2, and then the x is going to be sigma 3. Okay, so if we plot sigma 3 here, what we can do is we can draw another Mohr circle for that stress, and then our tau max in this case would be equal to sigma 1, sigma 2 minus sigma 3 over 2. And then for our last element, element C, if we draw that, we would get sigma 1 along the horizontal and sigma 3 along the vertical. And if we drew that Mohr circle, we end up getting this element here, where the maximum shear stress would be equal to sigma 1 minus sigma 3 over 2. Now, so in conclusion, if we rank our principal stresses from our greatest principal stress being sigma p1 and our minimum principal stress, what I mean by minimum is the most negative principal stress, and we can then say that the maximum shear stress on the element would be equal to the first principal stress minus the third principal stress divided by 2, based off of the Mohr circle. So, so, so we're going to talk about some practical cases of stress and how they relate to the corresponding stresses using 3D Mohr circle. So, the first case is for uniaxial tension. So in this case, our stress element just looks like this. Okay. In this case, the sigma x is going to be equal to our first principal stress, and then sigma y is 0. All right, and then the sigma z would also be 0. So these are our sigma y and sigma z are our second and third principal stresses. So what we end up getting is, if we draw our Mohr circle, is that our maximum shear stress would be equal to sigma x, or sigma 1, sigma p1 minus sigma p2, or over 2, which would be the same thing in this case as sigma p1 minus sigma p3 over 2, because sigma p2 and sigma p3 are both equal to each other and they're equal to 0. So what we end up getting is we just get sigma 1 over 2, or the maximum shear stress in this case is just equal to our first principal stress divided by 2. In the second case that we're going over is biaxial stress. So this is the case where you would have two stresses acting on a system. So if you had a case where you had two stresses, sigma, let's say sigma 1, which is sigma x, and we have sigma 2, which is sigma y, all right, acting on an element. All right, sigma stress in the third axis is going to be equal to 0. If we drew a Mohr circle based off of this case, if this was our sigma 1 and this was our sigma 2, what we'll notice when we are based off of this Mohr circle, our tau max would be equal to sigma 1 minus sigma 2 over 2. However, we do need to account for the third principal stress in this case, which would be along the z-axis. So sigma 3 is going to be equal to 0. So that would be located here. Even though it's not applying a stress, it would still affect the maximum shear stress in the system. So now if we draw this Mohr circle, all right, the true tau max is going to be equal to sigma 1 minus sigma 3 over 2. Okay, so please, in all situations, make sure that you account for all the principal stresses, not just the stresses that are acting on the element. So if you have a case of plane stress and there are two positive stresses like we've talked about here, your maximum shear stress is really going to be equal to sigma 1 minus sigma 3 over 2, which is just going to be, in this case, sigma 1 over 2. All right, since sigma 2 is positive, this estimate is going to be underestimating your true maximum shear stress. All right? So the last case we're going to talk about is if the case of you have an element that's in pure shear. So you only have shear stresses acting on the system. Oops. All right. So since our shear stresses, our normal stresses are 0, we can plot our Mohr, when we draw our Mohr circle, what's going to end up happening is it's just going to be centered about the origin point here. All right. And then our three equivalent principal stresses are going to be equal to sigma p1 is going to be equal to tau xy, sigma p2 is going to be equal to 0, and then sigma p3 is going to be equal to negative tau xy. All right? So those are our three principal stresses that we could determine from this equation. All right? Cool. All right. All right. So that